Alright guys, so I'm going to break these into several videos, probably one per page. I know each class I did different things, so if you've already gone over these problems or I've gone over them with you, you can skip to what you need. And just assume each video is probably about each page, unless I break it up differently. So let's start with problem number 1. You have to find several angle measurements, and you're starting with two triangles, pretty much a line, and one of the triangles has a line extending through it. So several things you should notice is you have an equilateral triangle right there, an isosceles triangle right there. And that's one of the main things you're going to start to kind of help yourself out. So probably the easier of the two would be the fact that this ABC is equilateral. You should know that equilateral means equiangular, and every angle is 60 degrees. Okay, so that's a pretty easy place to start. Over here, you have this isosceles triangle. With this being 50, these two angles have to add up together to 180, but they're also congruent. Okay, so finding that, you're going to do 180 minus 50, cut that in half, and each angle is 65. So 65 there, 65 there. This angle here, this 65, and this exterior angle are a linear pair. They're going to add up to 180. So 180 minus 65 is 115. You got that angle there. Here, if you look, you have 65, this angle, and then a 60. If you add 60 and 65 together, that's 125. If you take that away from 180, that's going to give you this angle here, which is 55. Then that pretty much just leaves you down here in the corner. You should be able to see that these are vertical angles here at A. Let me get some of this work out of the way here for a second. And so because of the vertical angles, this is congruent to this, and these two will be congruent here. Okay, so with that angle at A being 60, specifically, let me move those marks for a second. Specifically right there, this is going to be 60 because it's vertical angles. And then these two have to make it add up to 180, so you get 120, 120. Okay, so now if you look at the 6 problems you have on the side, you can kind of just look at your picture and figure out what angles are what. Alright, so if you look at A, you're looking at BCA. For those of you that have trouble remembering how to use the 3 letters, just trace it. Start at B, go down to C, across to A. Okay, it makes an angle right there. What's that angle measurement? 60. Okay. Second one, or question B, DCE. D to C to E. Okay, that's right there. That is 65. Alright, so question C, D, E, F. D, E, F. That's this exterior angle over here, and you can see that's 115. I'm going to pause for a second and see if I can erase some of this stuff up here, and maybe redraw it just so we can get some of this. Let me move it in. Yeah. So let's go from there. And I'm going to go back a second, and hopefully you have your work there so you can remember where all your angles are as I use this. But you get 65, 65, 115, 55, 120, 120, 60. Okay, so we'll keep going. BCD, BCD. That's that one in the middle. That's 55. BAG, bag, is this exterior angle over here, 120. And the last one, GAH, is this angle right here, that vertical angle, and that's 60. Okay, so, pause it if you need to. Look at those angles. You can go back and look at the previous part of the video and make sure you've got every angle and how we got there. Okay? Alright, so moving on to problem 2. What is the value of x and y? So again, you got to notice very clearly the markings we have here. You have congruent marks here, 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 and here. If you look at this as two individual triangles, that actually creates two isosceles triangles. So here, this angle would match this angle. This angle, would match that angle. And then some of these, of course, x and x, so they should be the same, and these are vertical. So really, you have two identical triangles if you realize that. If not, we can kind of do the math to it and get there anyways. So if you take a look at this triangle on the left here, you have 75 degrees. So we're going to do 180 minus 75, which is 105. And then because those two angles are congruent here and here, you need to divide them in half. So 105 divided by 2 is 52.5. And that's going to be here, 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 and here. So x is 52.5. Now, like I said earlier, hopefully you noticed that these are two congruent triangles, but even if you didn't, to get y, you could add 52.5 and 52.5 and get 105, subtract that from 180, and you would get y equals 75. Or, of course, like we said, if you realize they're two congruent triangles, then that angle and that angle would be congruent anyways. Okay, so that's problem number 2. All right, problem number 3. There's nothing really to solve. You need to know what an altitude is. If you look earlier on the classroom, I don't remember exactly how many weeks ago it was, I put up the official notes that go over all these segments, what they should look like, their definitions. An altitude is height, and it's perpendicular. It goes from a vertex or an angle, and it's perpendicular to the other side. So first off, pretty clearly, the only perpendicular line you should see goes right there because of the 90-degree angle. BD goes straight down. That's simply your altitude. It's really not a difficult problem. You just need to understand what that is. And the last problem here, we have some graphing to do. It's a good idea if you haven't been doing this to have your paper out because, trying to move this around, sometimes I can't keep everything on the page at the same time so I can make this big enough to show work. So on this problem in particular, it's a good idea to be looking at your paper, but you got to plot the points and classify the triangles. So we have A at -1, 1. We have B at 5, 3. And we have C at -3, -5. Alright, and I don't think these lines are going to be drawn really well. So let me see if this works. Kind of. At least not super bad. But there you have your triangle. Now, we're talking about classifying, and we've done this so many times. Those of you that still get confused by that, you're just asking for names, and you just have to know how they differentiate. There's names by angles, and there's names by sides. Now, normally I tell you not to assume anything when you look at a drawing, but that's usually because the second part of that statement is because it may not be drawn to scale. Well, your grid, your graph is a scale. You literally have the units there. So you can make more assumptions here. Looking at the angle measurements, if you look at angle A, that's obviously an obtuse angle, which makes this triangle an obtuse triangle. Okay, there's no two ways about that. And then for sides, either all three sides are the same, two sides are the same, or no sides match. Very clearly, CB is not going to match AC or AB. Now, it's possible AC and AB match, but we need to know for sure. Now, normally we would use distance formula like we talked about in class, but there is a way to do this a little bit easier. If you think of it like slope, though, you can make a right triangle going up and over. Now, I went up 6 over 2, and I made a right triangle there. I can do the same thing from A to B. I go up and over. I made a right triangle, and it's up 2 over 6. If you notice, I pretty much made it, I mean, if I did this, drawing accurately, the same right triangle here as I did there. If that's true, these two segments would be the hypotenuse, and using Pythagorean theorem, you would get the exact same length. So they're going to be congruent. That makes this isosceles. So again, it's a benchmark, it's multiple choice. You're not going to have to show work, but there's some ways to kind of do that. And later we'll talk about why Pythagorean theorem is the same as the distance formula. So that'll probably conclude video 1. The next video should be on page 2 of this worksheet. And I'll see you over there.